So the topic of discussion today is 5G network slicing. Now, in order to understand what is 5G network slicing, we must recap. What is 5G? It is the fifth generation of wireless technology. It is ultra fast, it has low latency, and it connects millions of devices. So, in comparison to previous generations where 4G offered 1 gigabits per second of speed, 5G offers 10 gigabits per second. Think of 5G as a superhighway for data, but not every device drives the same way. Now, what is the problem? Different applications have different needs, like gaming requires low latency, your IoT sensors requires reliability, your streaming requires high speed. So therefore, one network isn't enough. The solution? Network slicing. We divide one physical network into multiple virtual slices. Each slice serves a specific purpose, like having dedicated lanes. So the core features of 5G. Firstly, we have ultra-reliable, low-latency communication. This delivers low latency and high reliability for uses like autonomous vehicles or other automation. Then the eMBB, which provides higher data rates and stable internet speeds. Then the massive machine type communication, which connects vast numbers of IoT devices, enabling smart cities. So the network slicing architecture looks something like this. Firstly, we have the service layer. It connects each slice to its purpose, like IoT, video, or critical communications. Then the network function layer, it uses virtualization like cloud servers to create multiple logical networks. So each slice gets its own network function, like routing or security. Then the infrastructure layer, this is the real hardware. It has the antennas, the servers, the base stations, and it's saved and it is shared among all slices. Now, 5G network slicing works something like this. It is built on software-defined networking and network function virtualization. It uses logical partitions of a single network. Each slice is an independent virtual network with specific quality of service. They are managed by a network slice manager, and it works through core, transport, and RAN layer. A step-by-step process would look something like this. Firstly, creating a slice. The network operator defines the parameters for each slice, including bandwidth, latency, and security requirements. Second, the resource allocation. The NSM maps those SLAs to virtual resources like CPU, memory, radio resources to transport bandwidth, and then it reserves them. Lastly, isolation and management. Each slice is isolated from the others, providing independent network functions, management, and control. The NSM enforces the QoS, scaling, and fault handling, so no one slice would affect another. So this is an overview of what we just discussed. Here you can see each color band represents a virtual 5G network slice running end-to-end across the RAN, the transport, and the 5G core layers. These slices are dynamically created using SDN and NFV to meet specific services need, such as eMBB for high data rates, URLLC for ultra-low latency, MMTC for IoT connectivity, while all of them share the same physical infrastructure as seen here. So as you have seen, network slicing has quite a few advantages. So to recap, it tailors services and resources for specific applications for better performance. It improves the quality of service, guaranteeing low latency and high bandwidth. It secures multiple tenants, which secures isolation. It is cost effective as it optimizes the resources. It is flexible as it allows dynamic configuration. It has enhanced security because it provides isolation between the slices. However, it isn't without disadvantages. So some of these disadvantages include complexity and overhead. So managing these multiple slices adds to the complexity, so therefore it requires specialized experts as well. Then resource contention. Shared infrastructure can lead to issues if these resources aren't allocated efficiently. Then high investment. Then privacy. Different slice requirements may cause compatibility issues and poor isolation and can raise privacy risks. So yeah, that was all about network slicing in 5G networks.